Okay, let's do an example of a limit at infinity. And let's do a fairly complicated example. A limit at, no, not a limit at infinity, an infinite limit. So this is the one that involves vertical asymptotes. So infinite limit example. Okay, so let's say that you wanted to find the limit as x goes to 0 of cosine to the fourth x minus 3 all over x to the fifth power minus 2x. Okay, take a moment and see if you can do it. Okay, let's take a look at this problem. So the first thing you should do to get an idea of what's going on is to plug in 0, right? Now if you plug in 0 into the top and bottom, what do you get? So if you plug in 0, cosine, this is cosine of x to the fourth power. So cosine of x is 0. Cosine of 0 is 1. 1 to the fourth power is 1. So you get 1 minus 3 over, and on the bottom you get 0 minus 0 is 0. So you get negative 2 over 0. Well, obviously this is undefined because of the 0. And I noticed that the numerator is not 0, right? So that means that I'm going to have a vertical asymptote. And so the limit is either going to be infinity or minus infinity. Now remember, when you have something like negative 2 over 0, you don't necessarily know whether it's plus infinity or minus infinity. And the reason is because the denominator can approach 0 in two different ways. It can either approach 0 and be positive, so that would be like approaching 0 on the number line. You know, if you draw a number line like this, and here's 0, well, if you approach this way, the values are positive, and then if you do a negative over a positive, you get a negative number. So in that case, the limit would be minus infinity. But if you approach from the left, then the denominators are negative, and then if you do negative over a negative, you get a positive. So then the limit would be positive infinity. And so you have to pay attention to, are these values of the denominator positive or negative? Well, you're going to have to evaluate the one-sided limits. So we look at the one-sided limits. So let's look at the limit from the right. X goes to 0 from the right of this. Well, you're always going to get negative 2 on the top, but on the bottom, what's going to happen? Well, on the bottom, so x to the fifth, let's do red, that's approaching 0. 2x is approaching 0, right? 0 minus 0, that doesn't really help. However, you can factor the bottom, so x to the fifth minus 2x is x times x to the fourth minus 2. And this gives you an idea of what's going on when x is approaching 0 from the right, right? What happens is that x to the fourth minus 2, that is approaching negative 2, and x is approaching 0, but it's positive, right? And it's positive. So I'm not saying the 0 is positive, I'm saying that x is approaching 0 and x is positive. And x is positive. And so the product is going to be positive or negative. Which one? It's going to be negative, right? this guy, x times x to the 4th minus 2 is going to approach 0 and be and be negative. And that's what the little symbol notation means, that it's approaching 0 but is also negative. It might be better to make it less confusing, to say it's approaching 0 and is negative. So what's going to happen with this limit is that this is going to be, well, on the top you're going to get negative, it's going to approach negative 2, and then on the bottom it's going to be approaching 0 and being negative, and so this ratio, right, this quotient is going to be positive, and so it's going to be positive infinity. Okay, now let's take a look at the other direction, the limit from the left. Well, now, right, the numerator is going to be, it's going to approach negative 2, and then the denominator is going to approach what? Well, it's going to approach 0, but is it going to be positive or negative? Well, again, I have the denominator is x times x to the 4th minus 2. As x goes to 0 from the left, that guy is going to approach 0 and be negative. And the x to the 4th minus 2 is going to approach negative 2. And so when you look at the whole thing together, you have a product of negative numbers, that's going to be positive. So that's going to be 0, that's going to approach 0 and is positive. So the denominator in this case is going to approach 0 and be positive, and so the limit's going to be minus infinity. Okay, and so the limit doesn't exist because the right-hand limit is approaching infinity and the left-hand limit is approaching negative infinity, so the limit doesn't exist. Right. Instead of writing this all the time, let's just call this f of x. So the limit from the right doesn't equal the limit from the left. The two-sided limit doesn't exist. Okay? So you have to be careful with the infinite limits. I mean, a really common mistake is to just, what a lot of students will do is they'll just go here, and then they'll just say that the answer is minus infinity. Okay, but that's wrong. You have to look at what's happening to the denominator, and you have to look at the one-sided limits. Unless you can tell, that it doesn't matter which direction you're approaching. So for instance, let's just do another example. Okay. Let's say that you had, what's a good example? Okay, the limit as x goes to 0 of cosine x minus 2 over sine squared x. Okay. So again, we plug in 0 into the top and bottom, and if you do that, you're going to get cosine of 0 is 1, 1 minus 2 is negative 1. On the bottom, you're going to get 0. Right? Now you can't just conclude that the answer is going to be minus infinity. What you have to do is you have to look at the one-sided limits and see, is the denominator approaching 0 and being positive, or is it approaching 0 and being negative? And in this case, it doesn't matter which way you're approaching because you have the sine squared on the bottom. So as x goes to 0, right, sine squared x approaches 0 and is positive. And so the denominator is going to be positive, and then the ratio is going to be negative, and so the limit's going to be minus infinity. Right? But it's really important to say this. Okay, don't just say that the answer is minus infinity. So yeah. For instance, okay, let me see if I can come up with an example where it's negative in both directions. Let's say that you had, okay. Let's say that you had the same numerator, but then in the denominator, it was let's say it was x squared minus 2x, and then times sine x, like that. Right? Well, so again, the numerator is going to approach negative 1, and then the denominator is going to approach 0. And so now we analyze the denominator. Now this expression, okay, that's equal to cosine x minus 2 all over x times x minus 2 times sine x. Right, for these kinds of things, you want to try to factor this as much as possible and then see whether the individual parts are approaching positive or negative. So in this case, as x approaches 0 from the right, okay, let's look at each of these pieces. So the sine x, that's approaching 0, and it's going to be positive, right? It's going to be approaching 0 and is positive. The x minus 2 is going to be approaching what? Negative 2. And this x is going to be approaching 0 and is positive. So now what do I have? Do I have positive or negative? Well, on the bottom, I have positive times negative times positive, and that's going to be negative. Right? So as x approaches 0 from the right, I'm going to have a negative denominator. And so the limit as x goes to 0 from the right, I'm going to get negative 1 on the top, is going to approach negative 1. On the bottom, I'm approaching 0 and being negative. Right? And so the limit's going to be positive infinity. What happens as you approach 0 from the left? So again, I get negative 1 on the top, and on the bottom, okay, so sine x, that's going to approach 0 and be negative, right? Because if you look at the graph of sine x, it looks like this. So when x is negative and really close to 0, sine x is negative. Right, it's this wave like that. Okay, and then x minus 2 is approaching negative 2, and then x is approaching 0 and being negative. So now when you look at the product, it's also negative in the denominator. So I'm approaching 0, right, because I have a negative times a negative times a negative, that makes a negative. So I'm approaching 0 on the bottom and staying negative, and so the ratio is going to be positive, so the limit's going to be positive infinity. And now in this case, both one-sided limits are the same, and so we get that the limit as x goes to 0 of our function is going to be positive infinity. Right? Even though when you look at it, right, if you look at the initial thing we did, we got negative 1 over 0. But the point was that as x approached 0 on either side, the denominator stayed positive. stays negative, and so the ratio goes to positive infinity. So this is a common mistake that students make, is that they don't look at what happens in the denominator. It's counterintuitive a bit, because you might think, well, if the top is approaching negative 1 and the bottom is approaching 0, then shouldn't the ratio be approaching minus infinity? And the answer is, well, not necessarily, because the bottom might be approaching 0 and being negative, right? So then the sign would switch. Okay, so those are some examples of the infinite limits. And yeah, I mean, if you have a good understanding of these examples, then you probably have a good idea of how to do these infinite limit problems. Okay, that's all I have for this.